All right, Miss Aselson here today. We're talking about the probability notes addition rule versus multiplication rule. You've done both of these already. You've just done them separate. Today we're going to throw them in together and determine when would we multiply and when do we add probabilities. So when you're multiplying, you're going to find the word and as a key word for when you multiply. Okay? If you're going to add your probabilities, you're going to find the word or. Okay, with multiplication, when you're multiplying probabilities, you're either going to have independent or dependent. Remember, independent, that bottom number does not change, but if it's dependent, that bottom number will change. And when you add probabilities, you have exclusive or inclusive. Exclusive means when you have that both category, you're going to put a 0 there. If it's inclusive, you're going to have something, they're going to impact each other. That the probability of the first thing and the probability of the second thing impact each other. So that third line, you have, you'll have a number in there. Remember when we have or, we set it up like this. This plus this minus this equals this. Okay, and usually, not usually, but when you multiply, you have for sure 2 lines. You might have more after that, but notice that I'm multiplying in the middle when I have the keyword and I'm adding and subtracting when I have the keyword or. So let's look at a couple of these. Okay, what is the probability that you draw a jack or a king from a standard deck of cards? Well, I read this word or right here. So that or tells me right away I'm going to set it up like this, plus this, minus this, equals this. Okay, they're talking about a standard deck of cards, so I know my total is going to be 52 because there are 52 cards in a deck. Remember when you add or subtract, that denominator, oh, I'm putting that in the wrong, you know what, I have this all messed up. Let me try again on my lines here. So you have, oh, no, my pen's not working. This plus this minus this equals this. There we go, that looks better. So I have 52, 52, 52, 52. When you add and subtract fractions, that bottom number has to be the same. Then I'm going to look, the first thing I'm asking for is a jack, so I'm going to put a jack right here. The next thing I'm asking for is a king right here. And then this one's going to be both. Okay, so I'm going to look at my deck of cards. I have 4 jacks in a deck of cards. I have 4 kings in a deck of cards. I can't be a jack and a king at the same time. Those are 2 separate cards, so I'm going to put a 0 right here. And then I just take my 4 and my 4, and I get 8. And now I'm going to divide 8 divided by 52, and I get 0.153. Here's my hundredths. 0 stays the same, decimal stays the same, 1 stays the same. I'm looking at this 3. That 3 is going to tell that 5 through 4 or less. Let it rest. So I'm going to let that one rest, and I'm just going to leave it a 5. And that's going to be my final answer. You don't have to determine whether it's independent or dependent or exclusive and inclusive in that this time. You're just thinking about those things as you're reading through these. Okay, number 2 says, what is the probability that you draw a heart, a diamond, and a heart from a standard deck? And then there's also these words, without replacement. Okay, so I see the word and. So I know I'm going to multiply. And when I'm multiplying, I'm thinking, what do I want? I want a heart, I want a diamond, and I want another heart. So I know I need 3 lines. So here's my heart, and my diamond, and my other heart. Okay, when I'm talking about a deck of cards, right away I know the total is 52. So I'm going to start with 52. And then I have to think, those words that I underlined in red, without replacement, means I'm holding on to it. So now in the whole deck of cards, you have 51, and then you have 50. And now I'm looking, this one I wanted a heart, and then I wanted a diamond, and then I wanted a heart. Okay, right away when I look at my deck of cards, there are 13 hearts, there are 13 diamonds, and now I want heart again. Because I already used heart in that first line, we took one away. The probability, you do have a probability to get one, so you have to take one away. So now there are only 12 parts left in there. Okay, so I'm going to multiply my top, 13 times 12, and I get 2,028. And then I'm going to do the bottom, 52 times 51 times 50, and I get 132,600. And now I'm just going to divide those out. Because I'm dividing it out, I don't need this line right there. So when I divide those, I get 0.015. Here's my hundredths place. So I know I'm going to keep my 0 and my 0, 0.0. This 5 is going to tell that 1, 5 or above, so I'm going to give you a shove. So now I'm going to turn into a 2. Okay, what is the probability that you draw a spade or an ace from a standard deck of cards? A spade or an ace. Or tells me I want to set it up like this. This plus this minus this equals this. When we're talking about a standard deck of cards, my total is going to be 52. So below all of these, I'm going to have 52, 52, 52. Okay, I'm going to look at either side of my OR. The first one I want is a spade. The next thing I want is an ace. And then can this be both? Okay, so I'm looking at my deck of cards. My spade, well, there are 13 spades. Those are the upside down shovel-y looking ones. There are 4 aces. And then I'm going to look in my spade row. Are in any of the spade row, are there any aces? Yes, there are one of them. So I'm going to put that one right there. There is one of them, I should say. So 13 plus 4 is 17, minus 1 is 16. So I'm going to take 16 and divide it by 52. And I get 0.307 hundredths. 0 stays the same, 3 stays the same. 7 or 5 or above, I'm going to give it a shove. So that 0 is going to turn into a 1. I shoved it up 1. And then number 4, what is the probability that you draw a king, a queen, then I have this word right here, and a jack in that order with replacement? Okay, so I want a king, I want a queen, and a jack. So that tells me I need 3 lines. So king, queen, jack. So this one I want a king. This one I want a queen. And this one I want a jack. Okay? With replacement says if I take one out and I look at it, I'm going to put it back in. So this one is going to be 52. This one is going to be 52. And this one is going to be 52. Because I took it out, I looked at it, and I put it back in. Okay, when I look at my kings in my deck, there are 4 kings. I look at it, I put it back in. There are 4 queens. I look at it, I put it back in. And there are 4 jacks. I look at it and I put it back in. I'm going to multiply the top and multiply the bottom. And I get 64 on the top, 140,608 on the bottom. If I divide those, this is a good one. Everybody right now, put it in your calculator. 64 divided by 140,608. Normally, we say, I'm going to take this one, this one, this one, and this one. We're going to use those numbers to determine how we're going to round. Well, there are no actual digits besides 0, and 0 is a non-number, so we can't use that one. Okay, so we're going to have to keep going in our calculator until we actually have something. So I'm going to have a 4, so that's my first non-zero digit. And then I want my next non-zero digit so I know how to round it. So now that I have that, I can go ahead and round, but my rounding is going to be a little bit different because now I'm going to round to this place value, and that 5 is going to help us. So right away, I'm going to say 0.000, because those are all going to stay the same. This 5 is going to tell that 4. Well, it's 5 or above, so it's going to give it a shove, so it's going to turn it into a 5. Okay, that is it for this notes video. You just have to differentiate on today's assignment whether it is a and problem or whether it is an or problem. So go ahead and get those ones started. So you are working on addition rule versus multiplication rule in your practice.